The concept of indexes in databases is something that can be a good example of shooting yourself in the foot. Now, an index on a table is just a pointer to the data in the table. And what it really allows SQL Server to do is to view the table in kind of a what-if scenario. And then in that instance, it lets it find data really quickly. Now, here's the best way to think about an index. Think about the index that's printed in the back of a book. And so you get the book, and you look back there in the index for certain subjects, because the book is printed in page order, but the index represents that same book in a different order. It represents it in keyword or subject order. Most of the time, you're going to create a table in a database, and it is going to be in a certain order based on the primary key. However, there are times that you need to get to that data and query that data in a different order. So you may have it in order by the order date, but you may want to query from time to time about the particular customer who sold that order. How do we find that, and how does that exactly work? Well, the index makes finding that data much faster and much more efficient, but I want you to think about something here. When we've got an index in the back of the book, it helps us find any subject matter really quickly. However, if we go in and add 2 or 3 pages to that book, we've now changed our index. Every page after that change that we made, the index is probably wrong now, and the page numbers need to be changed. The same thing happens with our tables. When I put an index on a table, and then I go change the data in that table, it's going to inevitably change some of the index values, and they're going to have to be rebuilt or reconstructed, straightened out, corrected, whatever you want to call it. Now notice this real quick example here. I've got a table that's storing people's first and last names. You will notice that this table is in the ID order for whatever reason. This table has been put in ID order, but I need to query this table from time to time based on the last name. And so what I can do is create an index on the last name. Now this is a bit confusing. Notice the index is on the last name, but here's the actual index. Here are the pointers. And what this is telling us is, hey, if this table was in the last name order, this is the order that the table would appear in. And so let's take a look at the way SQL can now see this table. Same data, it just sees it in a different order. Now, how does this help SQL Server? Well, when I query based on last name, and I want to only find Allison James, when I look for James this way, I can't tell by looking at the last name what order it's in, and so I don't know if we have more than one person in our database with the last name of James. So I have to scan all 5 rows. Now, if this was 1,000,000 rows, I would have to read all 1,000,000 rows because I don't know if there's another James. However, in this table, since I know that it is in last name order, right? It's in alphabetical order, Ashley, Harris, James, Lee, Smith. Now when I tell it to return me everybody with last name James, it knows that it can start and go down, and once it sees James, it can return it. And once it finds the next record that is no longer James, it can stop. It doesn't have to check any further because it's in that particular order, and it knows it just reached the end of that range, and there are no more James in the database. What we've done is we've allowed it to limit the number of records that it has to look at to satisfy our query. That's the big advantage with indexes. Now keep in mind though, the big problem with indexes is if I come in here and add someone, add an ID 39 and their last name is say Brown, then that is going to change the indexes for all of these people because Brown's going to show up right here as number 2, Bob Harris becomes 3, Allison James becomes 4, and so forth. And so that index is going to have to be rebuilt or adjusted, if you will, to make sure that it's now correct. So here's the bottom line. Indexes will drastically speed up some queries. We'll talk about what I mean by some queries. And it can slow down, even drastically slow down, the process of inserting data and updating data in your table because those index numbers have to be maintained. Before we leave the topic, let me just kind of hit you real quick with the 3 types of indexes you're going to hear about and read about. First is the single column index. That's what we just looked at. We pointed a single column and say build an index on this in ascending order. Then there's what's called a composite index. That's where we use more than one column for the index. And a lot of people will do this, say last name, first name. If I index on last name, it's going to put all my last names in alphabetical order, but if I have 23 Smiths, it'll just be 23 Smiths there. If I go last name, first name, it'll be Smith Smith, but it'll put Adam Smith in front of Brian Smith. And then there's what's called a unique index. This just does not allow duplicate values. Now this is in effect what your primary key is, but you can also create other unique indexes on other columns in your table if you need them. And there's also something called a unique constraint that does the same thing, gives you just a couple of more functionalities. Won't get into that now. But that's a good basic overview of indexes and what they do for us and how they can come back and bite us a little bit. In the next couple of videos, we'll talk about indexing guidelines and how to create them and monitor them and so forth.